We're tackling the fundamental topic of loads for the FE civil exam, specifically dead, live, wind, snow, and seismic loads as defined by ASCE 7. You will absolutely see questions on this, and they are typically straightforward if you know where to look in the NCEES FE Reference Handbook. Let's start with dead loads, represented by the letter D. These are the permanent, unchanging loads, like the self-weight of the structure itself, concrete slabs, steel beams, and fixed equipment. An exam problem might ask you to calculate the dead load of a 1 foot by 2 foot reinforced concrete beam. Using the typical density for reinforced concrete of 150 pounds per cubic foot, you would multiply the cross-sectional area by the density. So that's 1 foot times 2 feet times 150 pounds per cubic foot, giving you a distributed dead load of 300 pounds per linear foot. A common trap is forgetting to include all the permanent components mentioned in the problem, not just the main structural members. Next are live loads, or L. These are transient loads related to the building's occupancy, like people, movable furniture, and non-permanent equipment. For the FE exam, you will not need to memorize these values. The problem will either state the required live load, such as 50 pounds per square foot for an office, or direct you to a table in the handbook. A typical question will give you floor dimensions, say 20 feet by 40 feet, and an occupancy type. Your task is simply to multiply the area by the specified live load to find the total force. The trick here is in the wording. Pay close attention to the exact use described, as a library reading room has a different load than the high-density stack area. Now let's discuss the environmental loads, starting with snow loads, S. These are geographically specific and depend on factors like exposure and the thermal properties of the roof. The exam will test your ability to use the simplified snow load formulas provided in the handbook. You'll likely be given a ground snow load and various factors, then asked to calculate the design roof snow load. It's a plug-and-chug problem, so your main skill is locating the correct formula and variables. Wind loads, W, are similar in that they are complex but tested simply on the FE. The key concept is velocity pressure, which is a function of wind speed, height, and exposure. You will be provided with the necessary formula and all the input variables. Your job is to perform the calculation correctly, paying strict attention to units. Seismic loads, E, are a bit different as they represent inertial forces from ground motion. The most common FE question involves calculating the seismic base shear, V. The formula will be in your handbook, and you'll be given the seismic weight of the building, W, the response modification factor, R, and the spectral acceleration parameters. The single biggest exam trap here is the variable W. Do not confuse the seismic weight, W, with the wind load, which is also abbreviated as W. This is a classic point of confusion that exam writers exploit. The most critical skill is using the ASCE 7 load combinations, which will be listed in the structure section of your handbook. You will never design for a single load type. You must calculate the effects from each load and then combine them using the provided factored equations to find the worst-case scenario. For example, a common LRFD combination is 1.2 times the dead load plus 1.6 times the live load. Another is 1.4 times the dead load. A problem will give you the calculated service loads and ask for the controlling factored load, meaning you have to run the numbers for the relevant combinations and pick the largest result. To help you remember the main load types on exam day, use this simple phrase, "Don't let silly weather engineer." This stands for dead, live, snow, weather for wind, and engineer for earthquake or seismic. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.